So, on to chapter 3. So, chapter 3 deals with linear functions. So, something that's in this form, y equals f of x equals mx plus b. So, for example, if I had this, again, f of x is basically the same thing as saying y. So, we want to graph this. So, if I want to graph this, well, this is a graph of a straight line. So, I only need 2 points. So, we'll pick a couple numbers for x. So, let's take the easiest 2, which are 0 and 1. Well, let's see, 4 times 0 is 0. 0 plus 2 is 2. 4 times 1 is 4. 4 plus 2 is 6. So now we can graph. So let's make a quick graph here. Put some marks on here. And again, this is the x, and then this is my y-axis. So the first point is 0, 2, so 0 on the x, 2 on the y. That puts me there. And the next one is 1, 6. 2, 3, 4, 5, 6, which is going to put me there. And then we can draw a line and connect our dots. And we get our graph. So we can talk about the rate of change. So average rate of change. Which is the change in y over the change in x, which again is our slope. And in terms of function notation, this is f of x. Let's see. Sorry. This is going to be f of x2 minus the f of x1 over x2 minus x1, or in probably the more familiar way you've seen this is y2 minus y1 over x2 minus x1. And then if the rate of change is constant, then you have a linear function. So what does that mean? So let's draw a table here. So let's say I have this table, x, y. And let's see, the numbers here are 2, 4, 6, 8. And then we have here 5, 8, 11, and 14. And we want to look at the rate of change, right? So if I look first at these 2 points, this is going to be 8 minus 5 over 4 minus 2, which is going to be 3 halves. Then if I look at this, this is 11 minus 8 over 6 minus 4, which is also 3 halves. And then lastly, if I look at these 2, 14 minus 11 over 8 minus 6, and this is also 3 over 2. So we get a constant number here. Right. So again, given my equation, f of x equals mx plus b, and if m is positive, then it is increasing. And if m is negative, it is decreasing. So, again, given our equation, y equals f of x equals mx plus b. Again, m tells you the slope of the line. B is going to tell you where the y-intercept is. So where does it cross the y-axis? So if I had f of x equals minus 4x plus 2, my slope is negative 4, and my y-intercept is going to be 2. And in this case, this function would be decreasing. So then you can look in terms of given a data set. And so you can have what are called a scatter plot. So a scatter plot will look something like this. You barely have just a set of a points, and you have just this plot of that data. So if you look at this one looks fairly linear. And it looks like it has a positive slope. Okay? And it looks like a linear plot. And I could sort of put in a line of best fit, which would go something like that for that data. Okay? Let's see, we could also have one like this. And again, we could have a set of points. And again, this one looks linear. And this time it looks like it has a negative slope. And again, we could put in a line that sort of represents what's going on here, going something like that. Right? All right. So we could have linear, okay? And then there's all other kinds of plots you could have, quadratics and so on. Right? And so talking about quadratics, we also have that in this chapter. Okay. So quadratics are ax squared plus bx plus c. Okay. And a graph of a quadratic is a parabola. Okay. And a basic graph of a quadratic would be this one. And this is y equals x squared. And then I could also do this one. And this is y equals negative x squared. So in terms of a quadratic, well, we have this thing here, which is at the bottom of the curve, is called the vertex. And over here, this would be the vertex. Right? Let's see, parabolas also have an axis of symmetry, which in these two cases is going to be the y-axis. So parabolas are symmetrical. And then in terms of my parabola, we got if A is positive, the parabola opens up and the vertex is at the minimum. So the vertex is at the bottom of the curve. And then if A is negative, the parabola opens down and the vertex is at the maximum. So in terms of those things we want to know about a parabola is going to be, well, where is the vertex? And so the vertex is given by this. The vertex is going to be given by minus b over 2a f of minus b over 2a. So that'll give me the vertex point. And then the axis of symmetry is given by x equals minus b over 2a. So let's go through an example of how this would work. So if I had y equals 3x squared plus 18x minus 3. Well, the first thing I'm going to do is label our a and b. So a is 3 and b is 18. So now for my vertex. Well, the x-coordinate is going to be minus 18 over 2 times 3. So minus 18 over 6, which will give us negative 3. Right? And so then the y-coordinate is going to be 3 times negative 3 squared, 18 times negative 3, minus 3. And this will be 27 minus 54 minus 3. And this will give us negative 30. And so my vertex is at the point minus 3 minus 30. The axis of symmetry is x equals negative 3. And this parabola opens up. And so my vertex point, in this case, is going to represent the minimum. Right? All right. Well, in terms of writing out a formula for this parabola, there is this vertex form of a quadratic. And so f of x equals ax minus h squared plus k. So when the formula is in this form, the vertex is given by h k. So then, for example, if f of x equals 3, x minus 4 squared plus 3, the vertex is given by the point 4, 3. And I also know this parabola opens up. And the axis of symmetry is x equals 4. Yep. So we can get that. Oh, the other thing we want to know about our parabolas, if we were going to try to graph this thing, would be, well, does it have in terms of x-intercepts? So, and that'll be given by this. If b squared minus 4ac is greater than 0, then has 2 distinct intercepts. If b squared minus 4ac is equal to 0, then 1 distinct intercept. then if b squared minus 4ac is less than 0, then no intercepts. So let's look at an example. So let's say we wanted to be able to do something like this. We want to be able to graph f of x equals minus x squared plus 6x minus 5. Now let's see, let's first do our vertex. Now it's going to be minus 6 over 2 times negative 1 minus 6 over minus 2, so 3. So that is my x. And then the y is going to be minus 3 squared, 6 times 3. So minus 9 plus 18 minus 5. This will give us 4. All right. So my vertex is at 3, 4. My parabola opens down. My axis of symmetry is y equals, no, x equals 3. Oh, let's see, what else can I quickly figure out about this? The other thing I can quickly figure out about this is that the y-intercept is going to equal 5. You have to remember the y-intercept, the x value is 0. Okay? So now the other thing we want to know is in terms of x-intercepts. Well, let's get those. Well, at the x-intercept, the y value is 0. So we're going to have 0 equals negative x squared plus 6x minus 5. Right? And so we want to factor this. And so we're going to get, let's see, negative x and x. And then we want, let's see, we have a, let's see, minus, a minus 5 and a minus 1, right? Okay. And equals 0. And then we can solve each one of these. So minus x minus 1 equals 0. Or x minus 5 equals 0. So let's see here. Let's take the x over. And then over here, let's take the 5 over. Okay. And so we get x is going to be negative 1. And x is going to be 5. All right, so let's see. So we have a bunch of stuff about my parabola. And let's see if we can sort of come up with a graph. So let's start plotting some of the stuff we know. All right. We need another one here, don't we? Yep, all right. So x-intercept, negative 1 and at 5. Those are those. Y-intercept is at 5. And that's going to put me there. Right? Right. And then in terms of my, sorry, not 5, right? Y-intercept is negative 5, sorry. That should have been negative, yep. Should be a negative 5, okay. Let me correct that. All right. Wiped out my whole axis. All right, let's put the axis back in here. There we go. All right, there we go. Better. All right. So y-intercept is -5. Gonna put me about there, maybe. There we go. All right. Let's see. My vertex point is the point 3, 4. 3 and that's not right. Let's see. Something's not right here. Hold on. Let me look at this again. Minus, plus. Oh, all right. We need to scratch that and go back. Something is definitely not right. We need to go back here. Something messed up. Okay. Sorry about that, but there is a mistake here. So let's correct that. All right. Let's do this again. All right. So let me do this. All right. One more time. Okay. So we had, let me do this again. 0 equals minus x squared plus 6x minus 5. I'm going to multiply everything by -1, which means x squared minus 6x plus 5 equals 0. Right? And now I'm going to factor this. So this is going to give me x minus 3. Sorry. What am I doing? Oh, sorry. Yeah. And so that'll give me. Lost my eraser again. Here we go. All right. So x minus 5, x minus 1. All right. X minus 5 equals 0, x minus 1 equals 0. And solve each one of these. Add 5, add 5, add 1, add 1. And so this will give me x equals 5 and x equals 1. That's better. Okay. Now we're in better shape. Okay. All right. So now let's plot. So we got 1, 2, 4. So 5 is here, 1 is here. Okay. Y-intercept of -5, which will be about here. Vertex at 3, 4, which will be here. There we go. And then we can draw our graph. And so we get a curve going something like that, right? And so, all right, now we got it all fixed up. And then my axis of symmetry would be this line going through there, right? All right. All right. Got it fixed. And then we can have, in terms of a quadratic model, and so for this, we're going to do an example of one of the things you'll see. And we want to maximize the revenue. And so x is equal to minus 6p plus 600. And revenue is given by x times p. And so revenue is going to be minus 6p plus 600 times p. So this will be a minus 6p squared plus 600p. And so, again, this is a parabola, and it's going to opens down, and the vertex, and so x is going to be minus 600 over 2 times negative 6. So minus 600 over negative 12, and this will give us 50. So that is in terms of the price. So the price is going to be $50. Okay. And so then the revenue is going to be minus 6 times 50 squared plus 600 times 50. And so this gives us a revenue of $15,000. And this will be the maximum revenue. Okay. Okay. And then we can figure out how many units were sold. The number of units sold will be given by the revenue divided by the price, and so there were 300 units sold. Okay. Okay. And then the last thing that is solving an inequality. So given something like this, 4x squared plus 9x is less than 6x. I'm sorry, this should be a 9. There we go. Okay. So again, it's a quadratic, so let's set it equal to 0. So let's move the 6x over. So we have 4x squared minus 6x plus 9 is less than 0. Right? And then we want to see if we can factor this. Right? And so we have, well, so this is going to be 2x minus 3 and 2x minus 3. And so both these are same thing, so I only have to worry about one of these. So 2x minus 3 is going to be, and we're going to set this equal to 0 and solve this. Add 3, 2x equals 3, and then divide. And we get 3 halves. Right. 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 And so we want equals 3 halves, sorry. Right, equals 3 halves, right? Well, let's look at my parabola we have here. Well, let's see. In terms of this parabola, let's figure out what's going on with this thing. Well, let's see. The vertex. Well, the x-coordinate is going to be 6 over 2 times 4, which will be 6 over 8, which is 3/4. And then the y-coordinate is going to be 4 times 3/4 squared minus 6 times 3/4 plus 9, which will be 6.75. Now let's see, the vertex is at the bottom of the curve. Right? And this parabola opens up. And so if I were to quickly graph this without really worrying about how exact I am, well, we said we got a vertex at 3/4 and basically 7. So my vertex is here, and my parabola opens up. Right? So this thing is never less than 0. Okay? And we can also figure this out by using what we had up on the previous page, was b squared minus 4ac. And if I plug in my numbers here, we got 6 squared minus 4 times 4 times 6. And if we do this out, this is 36 minus 48, which is negative 12. And there are no x-intercepts. Right? All right. And that will conclude this video.